Every single day, millions of people around the world unbox sleek, ingenious gadgets they discovered not in a store, but on their social media feeds. A portable blender that charges via USB, a finger-sized thermal camera that turns a smartphone into a diagnostic tool, a cube that projects a galaxy onto the ceiling. These objects appear almost by magic, summoned by an algorithm and delivered to a doorstep. But the journey from a raw idea to a finished product sitting on a desk is one of the most complex and least visible industrial achievements of our time. We are about to take you inside the vast, humming ecosystems where this transformation happens, the secret factories of the TikTok gadget age. These are not the sterile, silent labs of corporate research and development. These are cavernous facilities, often hidden in sprawling industrial zones where raw materials like aluminum billets, spools of copper wire, and vats of liquid polymer enter at one end, and perfectly packaged, ready-to-ship gadgets emerge from the other, 24 hours a day, 7 days a week. What we often see as a simple, novel toy is, in reality, the product of absolute precision, orchestrated by a silent symphony of machines and a highly disciplined workforce. Before we step inside this hidden world, we invite you to join us on this journey into the heart of modern manufacturing. If you find these deep dives into engineering and industry valuable, please consider liking this video and subscribing to the channel for more explorations into the factories that shape our world. The production of a seemingly simple gadget begins long before any assembly takes place. It begins with the arrival and preparation of raw materials, an operation of staggering scale and logistical coordination. Consider the housing of a typical gadget, perhaps a compact power bank or a mini projector. This shell often begins as a long, extruded bar of aluminum alloy delivered by the ton. These massive bars, gleaming under the factory lights, are fed into high-precision CNC machining centers. These aren't single machines, but entire banks of them, lined up in perfect rows. Their enclosed workspaces a blur of activity. Inside, high-speed spindles whir at tens of thousands of revolutions per minute, while cutting tools, guided by meticulously programmed code, carve away microscopic layers of metal. What was once a solid, anonymous block is transformed into a complex, hollow chassis, complete with precisely drilled holes for buttons, ports, and internal components. The process is so fast and so accurate that tolerances are measured in microns, thinner than a human hair. Fine, continuous spray of coolant washes away the aluminum swarf, ensuring the metal doesn't overheat and warp under the stress of such rapid cutting. These machining centers operate with relentless autonomy, their internal lights casting a sterile glow on the component being born, while outside, robotic arms stand ready to swap out finished parts for fresh, raw stock, keeping the line in perpetual motion. While metal is being shaped on one side of the factory on another, the heart of the gadget, its printed circuit board assembly, is taking form in an environment that is more controlled than a hospital operating theater. This is the domain of the surface mount technology lines, or SMT lines. Here, long, interconnected machines perform a delicate dance of placement and fusion. It begins with bare circuit boards, panels of copper-clad fiberglass, which are first coated in a precise layer of solder paste. This paste, a gray, viscous substance, is applied through a stencil, exactly like a high-tech silk screening process. Then, the board travels into the pick-and-place machines. This is where the magic of automation becomes truly visible. These machines are equipped with dozens of tiny high-speed vacuum nozzles that dart across reels of components, resistors, capacitors, microchips the size of a grain of sand. They move with such speed and accuracy that the human eye can only perceive a blur in a single second. A machine can place dozens of these minuscule parts onto their designated pads on the circuit board, held in place only by the tackiness of the solder paste. The coordination required is immense. Each component must come from the correct reel, be placed in the correct orientation, and at the exact coordinate. After placement, the board slides into a reflow oven, a long tunnel of carefully controlled heat. The temperature ramps up in precise zones, melting the solder paste and creating a permanent, conductive bond between the components and the board. Upon exiting, the boards are immediately passed through automated optical inspection systems. High-resolution cameras scan every single solder joint, comparing them against a perfect digital model. If a joint is even slightly cold, bridged, or missing, the system flags the board in an instant, removing it from the line for rework or scrap, ensuring that no faulty electronics progress any further. The coordination between these disparate processes is the true art of the factory. The entire facility operates as a single, synchronized organism, managed by a central nervous system of software. As the CNC machines finish a batch of chassis, an overhead transport system, a network of silent motorized rails, carries them to the next stage. Simultaneously, the freshly populated circuit boards, having passed their inspections, are conveyed towards the same point. This is where the human element becomes indispensable. In clean, well-lit assembly stations, skilled technicians sit at ergonomic workbenches. They are the bridge between the automated world of component placement and the physical assembly of the final product. A worker might carefully insert a delicate camera module into a precisely machined slot in the chassis, its ribbon cable so fine it feels like silk. They then mate this with the circuit board, ensuring all connections are secure before passing the unit to the next station. Here, another technician might install the battery, a process handled with extreme care. Lithium-ion batteries are powerful but sensitive. A single short circuit or a puncture during assembly could be catastrophic. Therefore, the process is designed with multiple safeguards. Robotic arms often assist in this stage, gently picking up the battery packs and placing them into the housing, while sensors monitor the pressure being applied. This human-machine collaboration is where precision meets adaptability. The machines provide the brute force and perfect repeatability, while the human provides the dexterity and judgment to handle the intricate final connections. The unseen intelligence of the factory lies in its constant, invisible monitoring and fault detection. Thousands of sensors are embedded throughout the production line, acting as a digital nervous system. They track everything: the temperature of a reflow oven, the vibration frequency of a CNC spindle, the current draw of a motor on the assembly belt. This data streams into a central control room, where engineers monitor the health of the entire factory on banks of large, high-definition screens. Artificial intelligence algorithms are now often employed to analyze this data in real time, looking for anomalies that a human operator might miss. For instance, an AI might detect a slight recurring variation in the placement accuracy of a specific pick-and-place nozzle, predicting that it will fail within the next few hours. The system can then flag this for maintenance, allowing a technician to replace the nozzle during a scheduled break, preventing a cascade of faulty boards and costly downtime. This predictive maintenance is the gold standard in modern manufacturing. When a fault does occur, the system is designed for fail-safe operation. Automated shutdowns can trigger in milliseconds. If a safety light curtain is broken on a robotic assembly cell, power is cut instantly, stopping a multi-ton machine in its tracks to protect a human worker. These redundancies are not just about safety. They are about protecting the immense financial investment represented by every minute of production. A single hour of downtime on a major assembly line can represent losses in the tens of thousands of dollars, not just in lost production, but in missed shipping deadlines and broken contracts. What the public never sees is the relentless 24-hour rhythm of these places. When the sun sets and the world outside sleeps, the factory floor continues to hum. Rows of robotic palletizers, their mechanical arms moving in hypnotic patterns, stack finished goods onto pallets with a speed and consistency no human team could match. Autonomous guided vehicles, or AGVs, navigate the factory floor using a network of lasers or magnetic tape. These silent, boxy machines glide through the aisles, each delivering pallets of raw materials to the start of the line and carting away finished components, their paths carefully choreographed to avoid intersecting with human workers or other robots. These systems are the invisible workforce, the circulatory system of the factory, ensuring that materials are always where they need to be. Another hidden secret is the management of energy itself. These factories are massive consumers of power, and efficiency is paramount. Sophisticated building management systems constantly monitor energy usage, dimming lights in unoccupied areas, adjusting HVAC systems to maintain perfect conditions for both machines and workers, and even timing the startup of heavy machinery to avoid peak electricity demand charges, saving millions of dollars a year. It is a world of perpetual, calculated motion, where the line between day and night is erased by the constant, unwavering glow of production. In the final stages of assembly, the focus shifts to finishing and packaging. Gadgets, now fully assembled, enter a final testing phase. Many are placed into custom jigs that simulate real-world use. A waterproof Bluetooth speaker, for example, might be subjected to a fine spray of water, while its audio output is analyzed by sensitive microphones to ensure the sound quality hasn't been compromised. A portable power bank might be automatically charged and discharged to verify its stated capacity. This is often a fully automated process, with rows of testing stations working in parallel. Products that pass are then prepared for the final human touch. At the packaging line, workers, often working in teams, perform the last visual inspections. Their trained eyes scan the product for the smallest cosmetic imperfection, a tiny scratch, a misaligned label, a speck of dust under the screen. This is the final gate, the last chance to catch an error before the product is sealed inside its box. Once approved, the gadget is carefully placed into its packaging, often by a collaborative robot or cobot, which works alongside the human packer. The cobot might present an open box at the perfect height and angle, while the human inserts the product and then passes it to the next station for the addition of the cable, manual, and warranty card. This final ballet of efficiency ensures that the packaging is not only fast, but also error-free. The boxes are then closed, sealed with precision, and labeled. High-speed inkjet printers spray shipping information onto each box, which are then sorted by destination and stacked onto pallets by the ever-present robotic arms, ready to be shrink-wrapped and loaded into waiting trucks that will begin their journey to distribution hubs and, eventually, to the consumer. The next time a finger swipes up to reveal a curious new gadget and that package arrives days later, the journey it has taken will be invisible but unforgettable. What was once a collection of raw elements, sand transformed into silicon, bauxite refined into aluminum, petroleum distilled into plastic, has been orchestrated into a coherent, functional object by a hidden world of colossal machines and quiet precision. The seamless operation of these factories, from the silent glide of an autonomous vehicle to the micro-accurate placement of a component invisible to the naked eye, is a testament to human ingenuity and the relentless pursuit of efficiency. It is a world of controlled chaos where the risks of failure are measured in millions and the cost of error is zero tolerance. Massive systems tended by skilled engineers and technicians work in perfect synchronized harmony, rarely seen and even more rarely understood. They are the quiet engines that keep the modern world turning, transforming fleeting digital trends into tangible physical realities. We hope this glimpse into that hidden world has offered a new perspective. We would be interested to hear your thoughts in the comments below. And if there is a particular factory process or a specific product whose creation you would like us to explore in a future documentary, please let us know.